Welcome back to Young Einstein. On our last video, we derived the formula for the sum of the first n terms of a geometric progression. In this video, we're going to apply the formulas that we derived. So before I get into this video, make sure you subscribe, like, and leave comments on other topics you want to know more about. So let's get this example. Find the sum of the first 9 terms of the GP. 6 minus 18, 54 minus 162, and so on. Find the sum of the first 9 terms of the GP. 6 minus 18, 54 minus 162, and so on. So let's get the solution. The sum of the first 9 terms of the GP. Okay, so this is a GP, is clearly stated, so there's no need to find out if it's an AP first, checking if there's a common difference, or checking is a common ratio. We already know that it's a GP. What we also have to do now is to find the common ratio. We're not checking if there's a common ratio. We know there's a common ratio. We just have to look for the common ratio. Just have to look for it. So what is clear in the question, clearly stated in the question, is that first of all, the GP, the first term in the GP is 6. So A is equal to 6. And also they also said that there are the sum of the first 9 terms. So n in this case is 9. So A is equal to 6, N is equal to 9. That's the two information that were clearly given. Another information we can easily get is our common ratio. Since we already know the first term, we know second term, you can use your formula for common ratio, T2 divided by T1. R is equal to T2 divided by T1. And T2 is minus 18, T1 is 6. So you simply do R is equal to minus 18 divided by 6, which will give you minus 3. So R is equal to minus 3. Now, R is equal to minus 3. You can notice that this value of R, that's our common ratio, is less than 1. Minus 3 is less than 1. So, since this value is less than 1, there's a particular formula that is easier for us to use. Particular formula for sum of GP that is easier for us to use. That's the formula Sn is equal to A, open bracket, 1 minus R raised to the power of n, close bracket, all over 1 minus R. Sn is equal to A, open bracket, 1 minus R raised to the power of n, all over 1 minus R. That's the formula that is easier for us to use. Of course, I said it before, you can use the other formula, you will get a correct answer. But it's easier to use this formula since the common ratio is less than 1. So let's just substitute the values that we have here. So Sn will become S9 because we're finding the sum of the first 9 terms. S9 will be equal to 6, open bracket, 1 minus, open bracket again, minus 3, close bracket, raised to the power of 9, close bracket, all over 1 minus, open bracket, minus 3, close bracket. So the A became 6, the R became minus 3, it became minus 3 both in the numerator and the denominator, and N became 9. So that's what I just did here, simple substitution. So in the numerator, inside the bracket I have minus, open bracket, minus. It's okay. Before you get there, you have to simplify the power part. That is the minus 3 raised to the power of 9. Using your calculator, minus 3 raised to the power of 9 will give you minus 19,683. Minus 19,683. So you have S9 is equal to 6, open bracket, 1 minus, open another bracket, minus 19,683, close bracket, close the second bracket, all over 1 plus 3. Now it's 1 plus 3 because that minus times minus, minus open bracket minus in the denominator part means minus times minus, and minus times minus is plus. So that's why I have 1 plus 3 in the denominator part. So what we have is S9 is equal to 6, open bracket, 1 minus, open bracket, minus 19,683, close bracket, close another bracket, all over 1 plus 3. Now, in the numerator, you also have another minus, open bracket, minus, which will give you plus. So you have S9 is equal to 6, open bracket, 1 plus 19683, close bracket, all over 4, because 1 plus 3 is 4. So the 1 plus 19,683 will give you 19,684. So you have S9 is equal to 6, open bracket, 19,684 all over 4. So this 6, open bracket, 19,684 means that you should multiply 6 by 19,684 684, which will give you 118,104. So Sn is equal to 118,104 all over 4. Dividing this, you will get that Sn is equal to 29,526, and that's the final answer. So that's the sum of the first 9 terms of the GP that was given. So let's get another example, example 2. Find the sum of the first 3 terms of a GP with common ratio 4 and first term 100. Find the sum of the first 3 terms of a GP with common ratio 4 and first term 100. So first 3 terms, meaning that the number of terms we're talking about is 3. So n is equal to 3. They give us the common ratio as 4. So r is equal to 4. They give us the first term as 100. So a is equal to 100. Now they give us r as 4. 4 is greater than 1. So in this case, r is greater than 1. So I'm using the second formula for sum of n terms of the GP. That's Sn is equal to a, open bracket, r raised to the power of n minus 1, close bracket, all over r minus 1. So we substitute the values that we have. Remember, a is 100, r is 4, n is 3. So instead of writing Sn now, you write S3 is equal to 100 because a is 100, close bracket, open bracket rather, 4 raised to the power of 3 because r is 4, n is 3. So that's 4 raised to the power of 3 minus 1, close bracket, all over 4 minus 1 again because r is 4. So 4 raised to the power of 3 that inside the bracket is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 will give you 64. So we have that S3 is equal to 100, open bracket, 64 minus 1. 64 minus 1 will give you 63. So we have that S3 is equal to 100, open bracket, 63, close bracket, all over 3. So multiply 100 by 63, you get 6,300. So S3 is equal to 6,300 all over 3. 6,300 divided by 3, you get 2,100. So S3 is equal to 2,100, and that's your final answer.